Good afternoon to all my friends and relatives and students. So we are to continue that physics class 11th. Second one is so we have finished this one. So the case one is body pushed against a vertical plane by the horizontal force and moving vertically downwards. So this is downwards. This force is in this direction. So acceleration is in this direction. So mass into acceleration will be in the opposite direction. To move it down. To move it up. So here we are. This will be MA. This will be mass into acceleration. The body pushed against the vertical plane by moving vertically downwards. It is moving downwards. So MA will be in the opposite direction. This we have already cleared in the yesterday lecture. When the body is pushed against the vertical plane by the horizontal force, this is the horizontal force F, and this is mg is equal to ma, because ma is in this direction and mg is in opposite direction. So this is mg is equal to ma, since the body is at rest. So next case is case number 2. So body is pushed against the vertical plane by the horizontal force and pulled vertically upward. So now the body is pulled upwards. So this is upwards. So the mass into acceleration will be in the opposite direction of this. This is ma. In this direction it will be ma, and mg is equal to, and force, there are two forces, and pulled vertically upward. There are two forces applied here. So when there are two forces applied on this, first is F1. The first number one is F1, which is acting in the horizontal direction, and the next force is upwards, which is acting in the vertical direction. So there are two forces now acting on the body. This body is being pushed by against the vertical plane. So vertical plane is this, and that is pushed upwards. This will be moving upwards. So this is moving upwards. So that is why acceleration is upwards, but the ma will be downwards. So the equation will be for the vertical direction. This is the vertical direction. So the force will be F2. F2 is in this direction. So we will write F2. So this is in this direction, and is equal to the ma plus mg. F2 is equal to ma plus mg. ma plus mg plus mg. So this is the equation. We have got it. When we take mg to the left direction, in this direction we take up. So then it will be F2 minus this equation we get for the vertical direction. We get the same equation by transferring mg towards in this direction. The next is horizontal direction. Horizontal direction is, this is the horizontal direction. So F1 is in this direction and n is in this direction. So we already get n is equal to F1. So this is case 2 is over. Case 3 is when the body is pushed against the vertical plane by the inclined force. Earlier there was horizontal and vertical forces were there. There were two forces acting on a body. So earlier it was horizontal and vertical, but now it is inclined force. This is the inclined force and accelerate vertically upward. So it is accelerating upwards. So in the downward direction it will be MA. So this is the theta, and this will be the base. Like if we have a triangle like this, we have a triangle like this. So if we join this line, then if we join this line, so this will be hypotenuse and this will be this is a triangle. So again I have to draw it, because this is the triangle. We will concentrate on it. This is not the triangle. We will concentrate on this triangle. To go in this direction. This is we have to join these 2 points. We have to consider this triangle. So this is F, and suppose this is f of y. Suppose this is f of y, and this is f of x. Then this is the base. This will be the base. Fy will be the base. So what will be the sine theta? Sine theta. So this is the sine theta is equal to p by h. So what is p? P is this one, f of x. F of x. This is f of x divided by f, because f is the hypotenuse for this. And then it is, we will take this in this direction. Then f of x is equal to f of x is equal to f of sine theta, f into sine theta, f sine theta, f sine theta. So in this direction, x coordinate direction, we have f of sine theta. This is proved. Now we go to the cos theta. Cos theta is equal to b by h, base by h, hypotenuse. So f cos theta is equal to b. B is this one, f of y. Please like my video and please subscribe my channel, because it encourages us. Please like my channel and subscribe my channel. Thank you for f of y. This will be b by h. Cos theta is equal to base. This is the base and this is the h. So f of y divided by f. F of y is equal to f of y is equal to f cos theta, f cos theta. So here it is written f of cos theta. This is in this direction, y direction, and this is in the x direction. So this direction, and f of sine theta is in the x-axis direction. So the case 3 is body pushed against the vertical plane by the inclined This is the case 3. Body pushed against the vertical plane by inclined force and accelerates vertically downwards. So body pushed against the vertical plane by the inclined. So it is the same here, but we have to take this triangle now. We have to consider this triangle, and here it will be the base. This will be the base, and this is F. In this direction we will consider it as F of y, because it is the y direction, and F of cos theta, this is in the F of x. This is F of x. F of x. So we will consider for the sine theta now. Sine theta is equal to p by h. Sine theta equal to p is this one, f of cos. P is this f of x. F of x. F of x by f. So this is we have to multiply this way. F of x is equal to f of x is equal to f of sine theta. F into sine theta f into sine theta f of y now. F of y is equal to cos theta, sine theta, cos theta, cos theta, cos theta is equal to b by h. So this is the base. This is the base f of y. F of y because divided by f. F of y is equal to f cos theta. F cos theta. So this is f cos theta in this direction, y axis, and in this direction it is f sin theta. So this is completed. Case 3. So this is tension in the light string. Force applied by any linear object such as string, rope is known as its tension. Tension means whenever we apply the force, suppose this is a string, if we apply the force, there will be some tension. Tension means there will be some movement of the string in upper and downward directions. So this is the same thing here. Since the string is highly flexible, flexible means like it can just basically like a rubber band. It's like a rubber band, and it can come back towards its original position. So force applied by any linear object such as string, rope, chain, rod is known as its tension. Hence tension of the string is always acts from the body to which it is attached irrespective of the direction. So this is the tension of the string being pulled always acts away from the body to which is attached. So this is the outside, away from the body. The tension is away from the body. It always moves outside, never inside, because inside means it is close to the body. So it is outside the body, that is, it acts in the direction of the away from the body. So this is flexible wire holding the lamp pole pulls the lamp in the upward direction and pulls the point of suspension in the downward direction. Suspension means where it is suspended. Suspension means from where it is suspended. Like this is a pole. So this is a pole like this. If we go for a pole, suppose this is a pole, electric pole. This is an electric pole like this, and here there is a light. So this light is attached to the wires. Let's look on going. So this is holding this. This is suspended over the wires. This is wires are tightened. These are the wires. Suppose these are the wires, and these wires are holding the lamp, the small bulb or lamp or whatever you say. These are the wires, and this is the like say bulb or light. You can say this is a light. So this is a light. This is a light, like light. This is a light. So it is holding. The wires are holding the light. So this is suspended. Suspended means it is through the wires. It is connected and this is suspended by the wires. So suspension means in the downward direction. Pulls the point of suspension in the downward. It is pulling. It is tightened. So the wires are tightened. Tightened means they are very tight motion. They are not loose. They are tightened here because so that it can hold the bulb there. If it is not tightened, the bulb will fall because it needs. Here it is written in the downward direction. Point of suspension. Suspension point will be this one. Point of suspension means from where the bulb and the wire are suspended. So this is pulling it downwards, but here it is staying because this is very tightened. These are the wires are tightened, and the point of suspension is this one. This is the point of suspension from where the bulb is, and point of suspension. This is the point of suspension now. Point of suspension. Suspension. So this is the point of suspension. Point of suspension from where the bulb has been held. So this is putting it downwards. Rope holding the bucket in the well pulls. So this is a well. Like this is a second example is the well. Well, this is the well in which there is a bucket here. There is a rope like here. There is a rope, and from where the bucket is been pulled down. So this is the bucket. Like this is a well. Well means this is the well, and this is there is a bucket here, small bucket like this, and we are holding a string over it. Rope is there, string is there. So this bucket is holding up this. A rope holding the bucket in the well pulls the bucket in the upward direction. So it is pulling the bucket in the upward direction, and the pulley in the downward direction. Pulley is in the downward. This is a pulley. Here it is attached in the downward direction. So this is an example of the physical applications. Physical applications of the tension in the light string. So this is the rope attached between the kettle and peg pulls the kettle towards the peg, and the peg towards the kettle. When a block is pulled by the chain pulls back the block in the forward direction, and the person holding the chain in the reverse direction. These are the examples of the physical examples of the tension in the light string. Light string and tension is there. So that is we are talking about it. So this is the key point. I move on toward the key point. In case of the light string rope, extension is same along their lengths. So this T1 is equal to T2. So this is consider a point P on the light string. This is the point P, and let the tension be either of it. Like this is in this direction. One tension is in this direction. Another tension is in this direction. So this is T2. They have given it as T2. T2 this is T1. So the T1 minus T2 is equal to MA. Strong accelerating towards the left under these forces. For the point P, the acceleration is in this direction. So A will be in this direction, left side. So in this direction, it will be MA. Because acceleration is in this opposite is the direction of the mass into acceleration. This has to be in the opposite direction, and T2 minus T1 is equal to MA. T2 minus T1 is equal to MA. This means T1, suppose we have to calculate this thing, then T1 is in this direction, T1 and is equal to T1 is equal to, in this direction there are two members, T2 and MA. T2 plus MA. T2 plus MA. So if we take T1, T2 there, we will get T1 minus T2 is equal to MA. T1 minus T2 is equal to MA. Because the MA, the direction of the MA is in this direction, because the acceleration is in this direction. Opposite of the acceleration is the mass into acceleration. The direction is opposite. So T1 minus T2 is equal to MA. So since the string is considered to be light, mass of point P is 0. Mass is very light, so we have considered it as 0. Mass is equivalent to 0 because it is very light. Mass is light, so we consider it as 0. Mass is light, very light, very light, very light. So we have light. So equivalent to M is equivalent to 0. not exactly equal to 0, but equivalent to 0. So we have considered this as T1 minus T2. So this quantity is 0 now. This is 0. We have taken it here. It is 0. So T1 is equal to T2. The next point is case number 1. Two bodies connected by a string are placed on a smooth horizontal plane and pulled by the horizontal force. So this is the center point, centroid. Centroid means where all the diagonals are meeting. So this is the centroid of the rectangle. The square, you can say this is the diagonals are meeting here. This is one diagonal, and this is the another diagonal. This is the centroid of the rectangle. So this is the center, you can say, or centroid. Here also the center is there, same thing. So we have two tension. The tension is from here, the left to right side and right to left side. So T, this is AMA will be is this direction. Acceleration is in this direction. M1A. The acceleration is in this direction, so this will be M1A. This is the one thing. First body. The second body is in this direction only, M2A. M2A. So the equation from this can be found like two bodies connected by a string are placed on a smooth horizontal plane, pulled by a horizontal force. So the equation will be M2 is equal to in this direction. And this is M2 is equal to M2G. So we can consider it as different bodies are there. So M2, this is the upward force. M2 is equal to M2G. M2G. For this body, N1 is equal to M1G. M1G. And here it is. In the horizontal direction, it is M1A is equal to F minus T. F is in this direction, right direction. Force has been applied here. Horizontal direction is F minus T. F is in this direction, and for this body only we are considering this body. This is in this direction, so F is in this direction and M1 is in this direction. So F is equal to F is equal to F is equal to T plus M. T plus M1A. T plus M1A. M1A. Okay. Now, the next is for this body. For this body it will be T is equal to, in this direction it is M2A, it is written here also, M2A. M2A, write it here, M2A. There is no F. F is here only. So we consider it as T is equal to M2A. T is equal to M2A. T is equal to T. Tension is equal to M2A. Equal to M2A. This is the two equations for the horizontal acceleration. This is for the horizontal acceleration. Horizontal acceleration, and that is for the vertical acceleration. Horizontal acceleration. This was the horizontal, there's no space actually. This is for the vertical acceleration. This is for the vertical acceleration. Vertical acceleration. It will take a lot of time to write this. Acceleration. So this is for the vertical acceleration, and that is for the this is and it is the same equations are coming here from this. Here is the same equation for vertical equilibrium of M1 and M2. And M1 is equal to M1G. This is we have got the same equation here also. You can see here. These are the same equations we have got. And another downward direction. Case 2 is when the two bodies are connected by a horizontal string, are placed on a smooth horizontal plane, pulled by an inclined force. connected by horizontal string are placed on a smooth horizontal plane and pulled by inclined force. So this is two bodies are connected by a horizontal string. Two bodies connected by a horizontal string and are placed on a smooth horizontal plane and pulled by an inclined force. So here the force is inclined. Okay. This is inclined. So in this case, we will consider this triangle now. So in every case the triangle is changing. Things are same but formulas are same, but the triangle is the shape of the triangle, everything is changing. This is, you have to join these lines, two lines now. You have to join these two lines now. From this vertex to this vertex. To join these two lines. You have to join these two lines, and this is the base now. This is the base. This is the base. This is the base, and this is the hypotenuse. This is F. So this like we have been there, cos theta is equal to, so cos theta, this is fx and this is fy, f of y. So this is fx, this is f of y. Cos theta is equal to cos theta is equal to b by h. This is b, f of x divided by f. Considering this triangle now, if it goes this direction. So f of x is equal to force in the direction of x-axis, because we have taken this triangle, and here base will be this, hypotenuse will be this, and perpendicular will be this. This is perpendicular. So f of x is equal to f cos theta. In the x-axis force, the answer is f of into cos theta, f of cos theta. Cos theta. So now in this direction we have to calculate the sin theta now. Sin theta will be p by h. Sin theta is equal to p by h. P कितना है? F of y. This is p. This is the perpendicular. So sin theta is equal to p by h. So this is fy by f. Fy by f. So fy is equal to fy by f. So we take up in this cross multiplication as done here. F of y is equal to f sin theta. F of y is equal to f sin theta. In the y direction, the value of the force is f sin theta. F of y is equal to F sine theta. F sine theta. So this is the answer in the y direction. So in this direction, x direction, this is f of cos theta, it is written here, and in the y direction, it is the answer is f of sine theta, f into sine theta. This is f into sine theta. So I was just clearing how it came, how it became that this way. So now we have to connect these two bodies are there. So we have to make the equation of this. Equation means how to make the equation of this, because this tension is up to this level. So the forces are here in this body only. You have to consider the forces in this body only, not this one. There's no force, there's only tension. T. So we have to make the equations of this, and we can continue tomorrow also. And thanks for watching and thanks for support. Please subscribe my channel and like my video. Thanks for watching. Thanks for support. Thank you.